Hello, dear students. I hope you must be awaiting for this session, right? So, how are all of you? You must have enjoyed the Diwali festival. Still, in some homes, it is still going on, right? It's not yet finished. So, hope everyone is enjoying and enjoyed a lot in Diwali, this Diwali festival. Now, and you must have a lot of fun and joy with your relatives, especially family members, right? So, from on behalf of all our Swiflearn team, I again wish a heart wish to each and every one of you on the occasion of Diwali, and let us make this Diwali more joyous by learning something new. Okay, so I welcome you, each and every one of you who are present now on our Swiflearn channel, online channel, YouTube channel, where you get to learn so many new things, exciting things about science, right? So here we go. Let us start with our session. We are going to discuss today on the topic of motion, right? Motion. So as soon as you heard this word, you know, what comes to your mind? Motion. What is the meaning of motion? Yes. What is the meaning of motion? Yes, motion means which has got some movement. Exactly. Very good. That's correct. Anybody else would like to say something about motion? And practically, in fact, nowadays, especially after the lockdown have been relaxed by the government, everyone is fed up by sitting in the home. They want to go out, right? So you must have traveled, gone out of your home during our Diwali festivals, and you must have seen so many things moving, right? So can you tell me one important thing about this motion? Let us see who can tell that. Yes. Yes, exactly. The position is changing. Yes. Any object whose position is changing with respect to time, that object is said to be in motion. Very good. Right. So here we go. I'll share the screen with everyone. Just give me a minute. Yes. Okay. So hope everyone is able to see the slide, and hope my voice is audible and continuous to everyone of you who's present now. Okay. So here we are to help you, to make you more and more studious and making your journey of study more and more joyful and excited, right? So Swiflearn, we are the team of teachers, dedicated teachers, which is the India's most sincere learning destination for classes 3 to 10. Okay. So we have these four main features. Those of you know, I'm just recapping whatever is there back. Okay. So we are 100% live, and we are having interactive classes. It's also personalized attention, batch with maximum of 6 students. Can you believe that? 6 students only in one batch, right? Nowadays, in any institution, if you go in any school or any coaching institute you go, so many students are there. But it's hard, very difficult for a teacher to, yes, personally interact with each and every student. So that's why our main purpose of keeping the maximum of 6 students is what? So that we can give personal attention to each and every student, right? That's the whole motto of learning, right? You should learn something when you come to the learning class, right? So that's the whole motto. So we have only 6 students batch. Then third is a dedicated academic and mentor team to track and work on students' progress, right? We have a dedicated team who work on how to improve the progress of the students, what we can do to help you to grow your results, to grow your ranks, to make you more and more progressive in your studies, in your learning. So we have a dedicated team for that. And then lastly, we cover all the syllabus, whatever the syllabus is there as per your CBSE board or ICSE board, whatever the topics are given, we cover entire the syllabus. And also we have custom requests, right? If somebody, having an exam, let's say in the next week, and if he wants to, he or she wants to undergo some tests, like exams, right? Subjective or objective or something kind of. So we also conduct that on the request. So you can request on our YouTube channel, right? So let us go ahead. These are our key features. The first thing is detailed progress reports, right? Because every parent, or in fact, every student wants to know how much I have been growing, how much I have been learning. So we have this progress reports in the form of chart or something like that, right? That also we provide. Secondly, Swiflearn academic test series we have, that is shortly called as SATs. So SATs is very famous for our team. Like, we conduct test series because, we must have a practice makes man perfect, right? So we strongly believe in on this statement, and we conduct so many practice tests so that a student can reach to the perfection of the answers, right? So we have the SATs also. Then we have unlimited practice tests. As I rightly said, we have so many practice tests conducted in our practice test exams. Then we have lastly subjective tests for school exams. Like in your school, you have this unit test or midterm exam and this and that, right? Subjective tests are there in your school, right? So for that, we conduct subjective tests as well, right? So please utilize all these wonderful facilities we are providing to grow yourself academically. Okay. So before I go ahead, please, those who have not registered till now and subscribed till now to our YouTube channel, please do subscribe and please press the bell icon which is there beside the subscribe tab so that you don't miss any of our live sessions. Okay. So everyone is ready, relaxed, comfortable, and ready to go ahead with the learning of motion. Right? Here we go. Let's start. Motion, describing a motion, right? As in the beginning of the session I discussed, motion means what? As somebody stated rightly, that is the changing of position of the object. Very good, that's correct. Motion means what? The object, if it is changing its position with respect to time, टाइम के साथ अगर उसका क्या हो रहा है, चेंज, पोजीशन चेंज हो रहा है, तो हम उसको क्या बोलेंगे? Yes, the body is said to be in motion. Very good. So these are the 5 topics we are going to discuss today. First is rest and motion. That's the first thing we are going to discuss. Then next is representation of motion in a straight line. Okay. How do you represent motion in a straight line? That also we'll discuss. Thirdly, we'll discuss about distance, right? Fourthly, we'll discuss about displacement, right? And fifthly, last, that is types of motion, which are the uniform and non-uniform motion. So these are the main 5 topics we are going to discuss today in detail. Okay. So first, rest and motion. Let us do that. So rest and motion. Now, I will ask you this question. Name some moving and stationary objects around you. Now the place wherever you might be sitting, in your room or in your home, right? So can you tell me some moving and stationary objects around you? There might be some moving objects. There might be some stationary objects, moving objects, stationary objects. Can you name them, please? Yes. Yes, exactly. The chair, the table, very good. You're sitting on the chair, you're sitting, your device is on the table, or even in fact, your device. You yourself is at rest, isn't it? You yourself is also at rest, correct? That is stationary objects. What about moving objects? Now you may say, sir, we don't have any moving objects around us because in the room everything is stationary. But yes, there are some moving objects. There might be. Let us see who can identify them. Yes, very good. If you look outside of your window, let's say if your house is road touch, you will see so many vehicles moving around, is it not? So those all moving objects, right? The vehicles which are changing their position. Yes, somebody said rightly, that is flies. You see the flies in the home. There is some one or two, of course. They are also moving objects, right? Moving beings, we can say. They are the living beings, right? They are not dead matter. They are the living beings, right? So they are also moving objects like flies or mosquito. Mosquito might not be there, right? So these are the moving objects and stationary objects. Very good, very good. So how can you differentiate between the state of motion and the state of rest of the object? See, the objects which are moving are said to be in a state of motion, and the objects which are stationary are said to be in state of rest. So moving means what? Motion. The object which is moving, as rightly said one of the student, that is the cars are moving, the vehicles are moving, is it not? So they all are moving, right? So that is they are in the state of motion. Very good. And then objects which are stationary. Stationary means their velocity is zero exactly, right? Now the main difference between the motion and the stationary objects is this. What is that? That the objects which are stationary have zero velocity, their velocity is zero, right? And the objects which are moving will have some definite velocity. That's the main difference you can see. There is another way also to identify which object is in motion and which object is in stationary condition. We'll come to that in the course of time in the further slides. Okay. So till now things are clear. Motion and stationary, right? Any object you see which is moving, as you can see this person who is riding on the bicycle, right? Leg riding bicycle, right? So he is in the motion. Although the picture has been taken the stationary, right? But he is since he is on the bicycle, so that's why he's moving, right? So he is in motion because its position is changing with respect to time, as you can see in the slide. Okay, let us go ahead. But how can we decide, sir, if an object is in motion or at rest? Yes, now you only tell me, you have given me the examples. How do you identify, okay, this object is in motion, this object is in rest, this object is in stationary condition? What is that prerequisite or the basic foundation or the fundamental difference you observe? Yes, anybody can tell me? How can we decide that? Any object is in motion and any object is in rest? Yes. Yes, very good, that's correct. So yes, how do you identify that? Motion and rest with respect to the surroundings. Very good. So with respect to surroundings, you have to have some reference, right? You have to have some reference to identify whether the object is in rest or motion. Another way is, yes, that is if the object is changing its position with respect to time, then that object is said to be in motion. Very good. Correct. So by observing the position of the object with respect to its immediate surroundings, right? Exactly, correct. So let's say I am sitting now here, right? Immediate surrounding I should check. If immediate surrounding is stationary, I am also in stationary. If the immediate surrounding is moving, that means I am in motion. Simple analogy, isn't it? Simple logic. It's not much difficult, is it not? Is it very difficult? Simple. As you can see in our day-to-day life, right? Let's say you are sitting in the car. So when you're sitting in the car, when you look outside, what do you see? The things are moving, like immediate things around you, that is next to you, right? So next outside the car, the objects are there, vehicles are there, the homes are there, the trees are there. They all are stationary or moving. They are moving, isn't it? It appears to be moving. Actually, they are not moving because you are in motion. That's why they appear to be in motion. That's what called as the magic of relativity. Okay, fine. That's another concept. We'll discuss that later on. So we have to. How do you identify basic fundamental is? How do you identify whether the object is in rest or in motion? It is by, yes, checking with the immediate surroundings. Very good. Correct. Thank you. Now you can see this in the slide. An object is said to be at rest if it does not change its position with respect to its immediate surroundings. So when the object is said to be in rest, when its position, the object's position is not changing with respect to what? Some reference we have today, as I said you, right? With respect to what its position is not changing with respect to its immediate surrounding. Its position is not changing. Then if this is the case, then the object is said to be in rest condition. Very good, right? Then the next line you can see this, an object is said to be in motion if it changes its position with respect to its immediate surroundings, right? So exactly opposite of the rest. Very good, correct. So if the object is changing its position with respect to immediate surrounding, if with respect to immediate surrounding, if I'm changing it, the position, then the object is said to be in motion. Very good. Is this clear? Now you can see this slide, the picture. You see this highway? On the highway there are many cars are moving, isn't it? There are many lanes. This side 4 lanes, that side also there are 2 lanes, and that side also there are 3-4 lanes, isn't it? So on every lane, can you see any object stationary or moving? Yes, cars are moving. Why? Because their position with respect to immediate surrounding. Now, immediate surrounding you can consider as a road, right? Or the barriers on the road, isn't it? Or this grass. Any reference you can take. So with that reference, the car is changing its position with respect to time. That's why they are in motion. Very good. So that is a basic differentiation or basic logic you can apply. how to identify object is in state of rest or in motion. Everything is clear till now? Yes. Anybody has any doubt? Okay. So rest and motion. Yes, clear. Very good. Great. Let us go ahead. To describe the position of an object, specify a reference point. Right. Immediate surrounding means what? You have to refer to as a reference point. That is very, very important. That's what I said to you. Reference point or the immediate surrounding. You have to take some reference. Now observe this slide. You can see in this picture. What you can observe? Yes. Anybody can tell me? Observe this picture carefully. Two pictures are there. Observe them carefully and tell me your observation. Let's see who can hit the right answer. Yes, you can see here in the first picture. You see this first picture? I'm pointing it out with the pointer. In this first picture, the car is very close to the street lamp. This is what? What is this? The yellow color border? This is a street lamp, isn't it? So with respect to street lamp, the car is yellow car is or taxi we can say. Generally taxi is yellow, especially in Mumbai, right? So this taxi is very close to the street light, right? But as you see in the second figure, what happens? The distance between the street line and car or the taxi is larger. Here the distance is almost zero. It's very close. But here it is there, some definite value is there. That means what? What is the conclusion? Yes, anybody can tell me what is the conclusion of this slide? Yes, very good. Because what is happening here in the first slide, in the first picture and in the second picture, right? In the first picture, the taxi is very close to the street line, and in the second picture, the taxi is little far from the street line. That means the car is in motion. Very good. What about street light, sir? Anybody? Street light, it is in rest or in motion? इसमें है वो rest पे है या motion पे है? Exactly, it is in rest because it's not moving. So reference point here we have taken as street light. As you can read this, a fixed point with respect to which an object changes its position is called the reference point or the origin. So here comes the definition of what is the reference point, what is the origin I have to consider. Here is the concept. So here I can take, there are different ways of considering reference point. Like somebody says, sir, I want to take a reference point as street light. Okay, go ahead, no problem. Somebody may say, sir, I want to take a reference point as this post box. You can see this letter box, right? Somebody may say, sir, I want to take the reference point as this grass. You can see this just beside this street lamp. Yes, any reference point you can take. There is some red color object, right, beside the letter box. That also you can take as a reference point. So any reference point can be chosen. With respect to that reference point, if the object is moving, that means it is in motion. Very good. Okay. So here we discussed the definition of reference point or the origin. Okay, let us go ahead. Now consider, you can see in this slide, there is one lady and there is one man. They are moving on the bicycle, right? If an object or body follows a straight path, okay. Now we are discussing about the motion in a straight line. That's very good. That's the next point, right? In the first slide we discussed my main 5 points, right? Now we discussed rest and motion. Now we'll discuss about linear motion or the representation of motion along the straight path. Okay. So if an object or body follows a straight path, then its motion is said to be a straight line or rectilinear or one-dimensional motion. The meaning of all these 3 words is same. Okay. Straight line, rectilinear motion or one-dimensional motion, right? When do we say the object is in straight line or in rectilinear motion or in one-dimensional motion? When the object is moving along the straight path. As you can see in this picture, this lady is driving her bicycle along this white color band. You can see this divider. Are you able to see my pointer? This white color band is basically what? It is the divider which divides the road, right? Which divides the road, right? And this lady is trying to drive that bicycle along this white band, isn't it? That means this lady is traveling along straight path, or the motion of the bicycle or the lady sitting on bicycle is rectilinear motion or one-dimensional motion. So these are very, very important terms. These are the technical terms you have to remember as it is. Okay, just keep them in mind. Okay. So rectilinear, straight line, or one-dimensional motion. One-dimensional, why it is called one-dimensional? Because it is moving only along one dimension. That's why it is called as one dimension. Is that clear? Right. Rectilinear. Linear means along the one particular line. That's how you can remember. Rectilinear means along one particular line. Right? That's how you can remember. That is called as rectilinear motion. Okay. Can you name some objects, bodies that follow the straight path? Yes, anybody? Now this is a question for you. Interesting question. Just think, give your churning, your thought process, what comes to your brain. As I gave example of this lady driving, the bicycle on a straight path. You can give some examples. Anybody? Let's see who can recollect. Yes, exactly. Very good. So the example, what is the example? Any ball, if you throw up, it comes down. It comes down in a straight path, isn't it? If you throw vertically up straight, then it will come vertically down straight. That is how it happens, right? Any other example? Yes, very good. If you take any object, right? Now let's say if I take this pen, right? This pen is there. If I take this object, it comes in the straight path, right? If I lift in the straight path and drop it, it comes in the straight path. So that's how you can define the straight path, right? So here are the examples. Motion of a car on a straight highway, right? Instead of bicycle, you can consider car also. March past of soldiers in a parade. This is very famous example, right? You must have seen that, especially on our Independence Day and the Republic Day on the DD National Channel, right? You must have seen on the Rajpath in New Delhi. You must have seen that all the soldiers, though they walk in the straight path, not even a single soldier's hand or leg gets mistaken the rhythm, right? You must have also that, isn't it? Every soldier, right, on right time exactly, they move the movements of their body and they walk in a straight path. So that is your which path? Straight path or rectilinear motion. Very good. And the third example is an apple falling from a tree. As I gave example of pain, the same. Let's say you're sitting below an apple tree and suddenly apple falls down. So that is which motion? That is a straight motion, straight path motion, because apple falls straight. Does apple falls the curvature path? No, it goes to your home and then it falls near you. No. So that is how it is a example for straight path. It falls down, right? Yes, because of the gravity. Yes, rightly said. Somebody rightly said that because of the gravity. Very good. Now let us go to the next. Representation of motion in a straight line. We discussed about straight path, right? A motion of a body along a straight path or rectilinear motion. Now, how do we represent that? We need to represent it graphically. So here, let us discuss now. A straight line parallel to the x-axis taken in the direction of motion is used to represent rectilinear motion. Each point on the straight line represents the position of the object at a particular instant, right? As you can see here, this is your straight path, or the markings are given 0 to 5 kilometer, 5 to 10 kilometer, 10 to 15 kilometer, right? 15 to 20, 25, 30, so on, so on, till 50 kilometer, isn't it? So you can see this, all these distances are measured in kilometer along horizontal path, that is along x-axis. X-axis means along the horizontal path. Y-axis means along the vertical axis. You might be knowing that coordinate system basics. You must have learned that in your maths, coordinate geometry. Okay. So each point on the straight line represents what? Position. If the object is at this position, let us say 5, you see this pointer, that means it is at a distance of 5 kilometers. With respect to origin, that is the reference point. Very good. Let's say if you take object at 10, that means it is at 10 kilometer from the origin. Very good. It is at 15 kilometer from the origin. Very good. Right. So that is how you can define the position of the object at a particular instant, at a particular time, right? That is how you can explain the position. Okay, let us go ahead. Now, here is one table given, the position of a stone falling freely from a building at different instants. And it is given in the table, okay? Represent the motion of the stone. It represents the motion of the stone. Now, recollect the example of apple, how the stone will fall. It will follow the straight path, or it will follow the rectilinear path, or curve path, or what? Yes, anybody? Which path it will follow? The stone. Exactly, very good. It will follow the straight path. It will come down straight, right? So time, if you consider time 0 to 1 second, 1 to 2 second, 2 to 3 second, 3 to 4 second. So when the time was 0 second, where was the position? 0. When the time was at 1 second, where was the position? 5 meter. Object was at, stone was at 5 meter. When the time was 2 second, object was at 10 meter. Sorry, 20 meter, right? Now this reference we are taking from the top of the building, okay? Position of a stone falling freely from a building. So starting is from the building, okay? Starting is from the building. So that is the reference point here, okay? So at 1 second, it is 5 meter from the reference point, that is from the top of the building. Then at 2 second, it is 20 meter. At 3 second, it is 45 meter. And at 4 second, it is at 80 meters, okay? So what is the height of the building? 80 meter from the ground, because let's say the object reaches, or the stone falls and reaches the ground in 4 seconds. How much distance it travels? 80 meters, right? So that means the height of the building, right? It's 80 meters, okay? So now you can represent this along this path, right? So at t equal to 0, the object present 0. That means you'll see this point as, you can give some name A, B, C, D also, okay? The first column A, second column B, third column C, fourth column D, fifth column E. So this would be a which point? A point. This would be a which point? Let's see, I can write it here. Just give me a minute. Let us give some namings to this, okay? Let us make something innovative. Okay. So let us make this as A, this as B, this as C point, this as D point, this as E point. Okay. Now, so A position, look at the A position at time t equal to 0, right? X is equal to, position is 0, that means this is your which position? This is your position of A, very good. Then at time t equal to 1 second, where is the position? Position is at 5 meter. So you see this is in meter, so 5 meter. This is your which point? B point, very good. Then the C point, yes, can anybody help me? Where to locate the C point? Yes, exactly. C point is at 20 meters. That is at 2 seconds. So this is your C point, location of C point. Very good. Then at time 3 seconds, where is the location? 45. So just measure 45. 0, 5, 10, 15, 20, 25, 30, 40, 35, 40, 45. This is the location for. This is the location for which? D point. Very good. This is your D point. And the last point is left now. Who will tell? Yes, anybody? Yes, measure distance from origin at 80 meter. So start measuring 0 to 80. Yes. So here comes the point. Which point I should write here? E point. Okay. So these are the different locations of the different points A, B, C, D, E. Interesting, right? Fine. So anybody has any doubt in this? Nobody has any doubt, then we'll go ahead. Right? So these are the different positions of the different points, right? So this is how you represent the positions of different locations of what? Stone, exactly. Stone is thrown from building, top of the building, and it is reached the ground in what time? 4 seconds. And how much distance it traveled? 80 meters. Okay. So this is how you represent. Okay. Any doubt so far? Okay. So let us go ahead now. Let me give me 1 minute. I'll rub this. Otherwise, it will disturb our other slides. So let us rub this. Work is done for this. Fine. Okay, let us go ahead. Motion is a change of position of the object with respect to its immediate surroundings, and it can be described in terms of the distance moved or the displacement. Okay, that is how you can represent the motion. So let's learn about distance and displacement now. Now, okay, whatever distance is measured, it is the distance, one thing. But what is displacement? Distance is very simple to define, isn't it? Everyone present in the class might easily tell what is displacement. Oh, sorry, what is distance? But displacement, anybody knows displacement? First, let us discuss about distance, then we'll go to the displacement. So take an example here. You can see this. Here is suppose a boy is there. Okay, here is a boy. He wants to go to his tuition. There's a tuition, right? And he took a longer route to reach his tuition. That is the route from his home to school and then towards the tuition. Home to school, that is home to school and then back to tuition. That is how you took the path. He took this path. Okay. Home to school and then school to tuition. That's what he took the path. Then the total path length covered by the boy is how much? A to B is how much distance measured? 0, 5, 10, 15, 20, how much? 40. Then B to C, how much? 40. 40 to 35, 5. 35 to 35. 30 to 25, 5. 5 plus 5 plus 5, how much? 15, right? So 40 plus 15, how much? Total is the 55 kilometer. That is how the total distance covered by the boy when it reaches tuition via or through school. Very good. Right? But there is a shorter distance also. Yes, anybody can tell me what is that short taking time distance? Let's see, you can tell me. Exactly, very good. That is from A to C. Why don't you go directly from A to? What is the work at the school? If there is no work at the school, right? School is already over, isn't it? In the evening you go to tuition, right? So there is no work in the school. What is the need to go to the school? I want to directly go to tuition, that's all. So the intelligent person will think like that, intelligent student, and that is what the intelligent student, one who gave the answer. That is, I want to go from A to C, exactly. Right? So A to C you go. How much distance you have to travel? 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, that's all. So A to C is what is called as distance or displacement. Yes, exactly. It's called as displacement. Now I want any one of you to give me the definition of displacement. Let's see who can crack the right definition of displacement. Yes, displacement is the shortest distance. Simple. It's the shortest distance. It is a distance only, huh? It is a distance because you have to travel from A to C. You have to cover a distance. You have to change your position, isn't it? That means you have to be in motion, right? See, all the things are getting applicable here in this example, right? Motion we discussed, rest we discussed, right? So, displacement. Displacement is what? A shortest distance traveled by the object. So that is what the next is, right? There are certain quantities for which only the magnitude is sufficient to give complete information. For example, distance. To describe distance, we need to specify only one numerical value, the numerical value, and not the direction of motion. Right? You must have heard about the scalar and vector, right? So scalar is that quantity for which you have to just mention magnitude. You need not mention direction. But vector is that which you need to mention two things. That is, first is magnitude. The second thing is direction. Very good. So for distance, do we need to mention any direction? Oh, distance means you have to go to this direction, north or south or east or west. No, it's just distance traveled. Whichever direction you follow, doesn't matter, isn't it? So total path. What is distance? Total path or distance covered by the object. How much is the total path covered? And second point, the path may not always be straight. It can be curved as well. It's not a rectilinear motion, right? We discussed about rectilinear motion. So is distance rectilinear? Not always necessary. It can be, but it's not compulsory. Okay. And SI unit is meter and CGS unit is centimeter. You must be knowing SI unit and CGS unit. SI is what? International System of Units. And CGS is what? Centimeter gram second unit. Right? There is a FIS also, MKS also. Very good. So these are the different systems of units we use. Earlier we used to use, but nowadays only we use what? That is SI system of units. That's the only thing we use. We don't use, right? CGS, MKS, FIS. They were the early use units or dimensions. But now we use only SI. And sometimes CGS also. Right? Okay, so let us go ahead. Is everyone is clear with this example? Right. Let us go ahead. Now, if the boy would have taken the shortest route to cover the distance between his home and tuition, it is A to C, then the distance covered by the boy would be how much? 25 kilometer, that is A to C. This is called as displacement. Right. So displacement is what? The shortest distance measured from the initial to the final position of an object is known as displacement. Shortest distance, simple, very simple. SI unit of displacement is meter and CGS unit is centimeter. Both the unit is same. Distance and displacement unit is same. Either it is SI unit or CGS unit. Okay. Okay. Remember one thing now here. For a given path, the magnitude of displacement is either equal to or less than the distance. It can never be greater than distance. Displacement is always less than distance. Distance can be equal to displacement sometimes, but it is never less than displacement. Distance is always larger. Okay. So total distance is how much? 55 kilometer in this example. A to B, then B to C. Right? And displacement is short distance 25 kilometers, and direction is A to C. Okay. So for displacement, you need to mention magnitude as well as direction. So it is a vector. And distance, just describe magnitude. That's all. Okay. Fine. Now here is another thing, another example. Let us discuss. Displacement can be zero as well, but distance cannot. Oh, let's see. If an object is thrown vertically upwards, let's say from point A to B, after some time, it will come back to the same point, that is at point A, isn't it? A to B and B to A, isn't it? So A to B means it's vertically upward, B to A means vertically downward, isn't it? So A to B, if it travels upward, straight path. B to A, if it travels downwards, it's again straight path, right? So straight path, upward distance, if I take positive, then downward I should take what? Negative, because direction is reversed, isn't it? According to the sign convention, right? If I take rightward positive, leftward you have to take negative, or vice versa also. It is not hard and possible. If I take upward positive, downward negative, or if I take upward negative, downward positive, any sign convention you can follow. So in this example, displacement is zero, but distance not. Distance is not zero. In this case, the distance will be 2 times the height, but the displacement will be zero, isn't it? Distance will be 2 times upward distance and downward distance. Same distance is traveled, but displacement is zero. Why? Let's say A to B distance is 5 kilometer, then B to A is also 5 kilometer. So 5 kilometer upward, if I take positive, downward I should take negative. 5 minus 5 is what? 0. Very good. That's how you can understand the concept. Okay. Now, the practical example for this is you must have traveled in the car. There is an odometer fitted in the vehicle. What it measures? It measures what? Distance traveled by the vehicle. You see this odometer? How much distance is traveled is this? Can somebody read this? Yes, very good. 35,992 kilometer. That's what the distance traveled by the car. And who is given by that? That is given by the odometer, which measures the distance. Okay. Now let us do something interesting. Okay. Let's open. Just give me a minute. So here is one simple example. Okay, very interesting. Let us do this now. What you can observe in this? Yes, you can observe here a car. Here there's a tree, right? There is no motion. Car is at rest right now. Okay. Now let us give some velocity. Okay, first let's discover position. Okay. Position. If I change the position, it is car changing. Position. If I change, motion is zero. Motion is not there. I'm just changing the position. You see, coming back. What I'm doing? I'm changing the position. Are you able to see this? S0. S0 is changing, right? So 112, then 120, then 132. So position is changing, but is it in motion? No. I'm just changing the position. The motion के लिए क्या होना चाहिए? Yes, velocity. Now see this velocity. Let us give some velocity. Okay. Okay, 28. That's good enough. So let us start now. Yes, here we start. You see, the car started move because I have given the car velocity. Exactly. So velocity is how much? Yes, as the velocity is, because it is moving with the constant velocity as the time progresses. You know, time is moving. You see, 18 second, 19 second, 20 second, and the car is moving. How many trees it is crossing? 26, 28, 30, 32. Are you able to see this? Interesting, no? Quite interesting. Are you enjoying? Great. So this is how, if I give the constant velocity to the car will start moving. Now let us go to the acceleration. Let us give some acceleration as well. Okay, something interesting now. Let's say velocity is 14 and acceleration if I give how much? Let's say 2. Okay. Now see the car how it is traveling fast because I am getting accelerated. The car is accelerated and acceleration will keep on increase as the time progresses. So initially little less, but as the time is growing, the car is accelerated larger and larger value, and that's how it is crossing the trees very fast. You see this 20, 22, 24, 26, 28, 30. You see this, right? So this is how the 3 things we discussed in this experiment: position, velocity, and acceleration. Right? Interesting, no? Okay. Fine. Hope you enjoyed this. Let us go. Anybody has any doubt in this? Clear? Okay. Let us go ahead. Now, this is the next topic for us in the session, types of motion, right? Probably this is the last topic in the session. Don't worry, this session will get over, but not the topic. Topic motion is going to be there in the next session as well. Uniform and non-uniform motion. What is this now? Let us discuss. Uniform motion. When an object covers equal distances in equal intervals of time, it is said to be in uniform motion. See these words. Equal distances and equal intervals of time. Then the object is said to be in which motion? Uniform motion. So these two words are to be noted down. Equal distance and, equal distance is covered in how much time? Equal interval of time it is covered. That's why it is called as uniform motion. Okay. So equal distance in same time is 10 to 20 kilometer 5 minutes, 20 to 30 kilometer 5 minutes, 30 to 40 kilometer. It should take 5 minutes because the velocity is constant. Uniform motion, always remember another thing is what? See, the distance traveled is what? Same. And time taken is also what? Same. That means what is constant? Velocity. Distance upon time is constant. That means velocity is uniform. So any object which is in uniform motion have which velocity? Uniform velocity. It's very important to learn, isn't it? Interesting, right? So examples, you can see this clock, right? In that second needle, hour needle and minute needle, they travel or they complete the one revolution in one fixed time, isn't it? That's why they are in uniform motion. Similarly, Earth rotating around the sun, that is also in uniform motion, isn't it? So these are the examples, uniform motion. Some of the examples of uniform motion: a car moving along a straight path at a steady speed. Speed is steady. Steady means what? Its position is changing, but its velocity is same with respect to time. That means another word you can say as uniform speed. Uniform and steady means same, meaning is same because its velocity is constant. Velocity is not changing. Second example is motion of planets around the sun as Earth is safe. You can take Neptune, Jupiter, all other planets, right? Mars, so on and so forth. So all these planets are revolving around the sun and they are taking a fixed amount of time to complete their one revolution. Because their velocity is uniform. That means they are in which motion? Uniform motion. Motion of a fan running at a constant speed, right? The fan running at the top of your head, right? You must have fixed up some speed, 1 speed, 2 speed, 3 speed, right? Depending upon the warmness or coolness surrounding you in your room, right? So the fan running at constant speed also another example for uniform motion. Very good, right? So everyone is clear with the uniform motion? Any doubt? Fine. Let us go ahead. Non-uniform motion. What is non-uniform motion? So here it is. When an object covers unequal distances in equal intervals of time, then it is said to be in which motion? Non-uniform motion. Okay. So object covers, now two important words here again. Unequal distances. What is unequal distances are covered in how much time? How much time? Equal interval of time, right? Unequal distances in equal interval. But for uniform, equal distances, equal interval, right? Remember, simple. These words are, if you just remember, you can frame the definition very easily. Uniform motion means equal words, equal interval of time. Non-uniform motion means unequal distances in equal interval of time, right? Uniform, non-uniform, clear? Uniform means unequal distances in equal interval of time. Sorry, equal distances in equal number of time, that is uniform motion. And non-uniform motion means unequal distances in equal interval of time, that is your non-uniform motion. You can see this example here. Different distance in same time interval, that is non-uniform. Okay, 10 to 35 kilometers. How much time it took? 10 minutes. So in 10 minutes, 25 kilometers covered. And then in the next 10 minutes, what happened? Yes, 35 to 40 kilometers. It took how much time? 10 minutes. Here, the larger distance is covered in 10 minutes, but in the next 10 minutes, the less distance is covered. So the speed of the car is decreased or increased? Anybody? Of course, speed is changing, no doubt, isn't it? Speed is, yes, increased or decreased? Exactly, decreased. Because in the first 10 minutes, it has covered 25 kilometers, but in the next 10 minutes, it has covered only just 5 kilometers. That means the distance covered is less. That means the speed or the velocity of the car is decreasing. That's it. That's what another word we call it as deceleration. Deceleration means what? The speed is decreasing. Okay. Any doubts so far? So here are the practical examples. You can see the vehicle moving in the crowd. You see these vehicles, small vehicles. There is a traffic jam, right? So they move ununiformly. Similarly, this bouncing of ball, you must have seen that, right? It also initially when you throw, the ball falls down with a larger velocity. As it takes the bouncing steps one after another, speed decreases. Very good. Let us go ahead. Some of the examples of non-uniform motion: a person jogging in a park, right? You must have seen. You must have gone also as well, right? The lockdown space sessions, especially lockdown period, in the morning, early mornings, right? Going for a jogging with you, might be your father or mother, right? Exercise that is ununiform. Dragging in a dragging a box, right? You're dragging a box. You're dragging with it. Let's say it's very heavy. So initially you apply a lot of amount of energy. So after some time, whatever the energy decreases, then you drag the box for less time, more time. Sorry, right? Because you get tired. The third example is bus moving through a market. Market, there are so much crowd, people, vehicles here and there. So bus moves little slow. Sometimes if the road is open, there are no vehicles or no men, then it moves fast. If there are vehicles and men on the road, then it moves slower. So sometimes slower, sometimes faster, sometimes slower, sometimes faster. That means it is which motion? Non-uniform motion. Okay. So hope everyone has understood the concept of uniform motion and non-uniform motion. Very good. Now let us have some question and answers. Okay. First question here is for you. Define rectilinear motion. Yes, anybody who would like to tell me? Rectilinear motion. Exactly. Rectilinear means what? Along the same path. Very good, very good. Congratulations. Rectilinear means an object is moving along the same path, one particular path, or along the straight line. There is another word used. Let's see who can recollect. Probably rectilinear is already used. There is another word, technical word. I told you to remember that. Let's see who can recollect. Yes, exactly. One-dimensional motion because the object is traveling in one dimension. That's why it is one-dimensional motion. Very good. Next question. Define displacement and state its unit. Unit basically I want here SI unit. Okay. Tell me SI unit. Displacement. What is the displacement? I told you two words to remember for displacement. Yes, exactly. Shortest distance. Very good. You are not so attentive in the class. That's great. Shortest distance is your displacement. Okay. And what is SI unit? Meter. Very good. When an object, third question, next question. When is an object said to be in motion? When do we say object is in motion? You remember in the beginning of the session, I asked you which are the objects which are stationary and which are moving. You told few objects. So what differences you made? And after that also we had discussed how to identify that as well. Let's see who can say that. How can we identify object is in motion? Yes, exactly. How? By checking with the immediate surroundings. Very good, right? Or another way is if the object is changing its position with respect to time, that means it is in motion. Simple, right? The lastly, that is define uniform and non-uniform motion. Uniform and non-uniform motion. Uniform, yes. Anybody would like to try? Uniform, not your school uniform, right? Not that uniform. Uniform motion I'm asking about. Mhm. Yes, uniform motion. That means the object is traveling with uniform velocity. So what are the two words for uniform motion? Equal distance and equal time. Very good. And what is non-uniform? Opposite of that? Unequal distance and equal time. Very good. So non-uniform motion has uniform velocity or non-uniform velocity? Of course, non-uniform velocity. It doesn't have constant velocity, right? Example is of that we did that experiment, right? Car is moving accelerated. You must have seen also a vehicles has accelerator, isn't it? Accelerator is there for the vehicles. So when you rotate the accelerator, what happens? The speed of the vehicle increases, right? So that is how we are increasing the speed or velocity. That means it is which motion? Non-uniform motion. Okay. Fine. These are the answers. Answer for the first one: if an object or body follows a straight path, then it is in which path? Rectilinear motion or straight line. Second, shortest distance. Definition of displacement: shortest distance covered from initial to final position by the body is called displacement. Sign it is meter. Third answer: an object changes its position with respect to its immediate surroundings. reference point, immediate surroundings, then it is said to be in motion. And the lastly, uniform motion and non-uniform motion definitions. Uniform motion is when an object covers equal distances in equal intervals of time, then it is uniform motion. Non-uniform is when an object covers unequal distances in equal interval of time, then it is uniform motion. Okay, great. So this is what we learned today. First topic we discussed rest and motion, right? Rest and motion. I asked you for a few examples, right? Let us go recap a few things, right? Whatever you can recollect. Rest and motion. What we discussed. I asked you the example, practical example. Some of you told me the chair, the table, all are in rest, right? Yes, Maki. Maki is in motion, or in the mosquito, right? Or if you look outside the window, right? The cars are moving, that is in motion. Very good. Then in the second point, we discussed about representation of motion in a straight line. In a straight line, how do you represent? You remember that along x-axis we wrote the distances, the table was given, right? Time was given, the distance travel was given, right? So that is how you represent the motion in a straight line, right? Horizontal path along x-axis, vertical path along y-axis. Of course, we used here horizontal path. We did not use vertical path, right? Distance. What is the distance? Yes, distance is. Do you remember that example? Yes, boy wants to go to tuition, so it takes a longer route. That is, first he goes to school, then he goes to tuition. That's a longer distance travel. How much was that? 40 plus 15, 55 kilometers. Right? So that is distance. Distance is what? Yes, the path traveled by the object from initial point to the final point. Is it necessary that it should be always straight? Yes, anybody? Distances should be always straight? No, it can be any direction. Right? And it is scalar or vector? Exactly, it's a scalar. Next is displacement. Yes, displacement is shortest distance. These are two words you have to remember. Shortest distance traveled by the object. That is what is called as displacement. Okay. Now, displacement is a scalar or vector. Means basically what I want to ask you is that for mentioning displacement, do you need to mention direction as well as magnitude or only magnitude? Yes, both you have to explain. That's why it is vector. But for distance, just you mention what? Magnitude. Okay. That's why it is a scalar. It is a vector. Right? Another question, I'll add the question for this. Displacement, can it be zero? Let's see, you can answer. No, exactly. Displacement can be zero. Yes. Distance. Can distance be zero? No, distance cannot be zero, right? Because for distance, we don't consider the direction. You remember the example of a ball throwing up and it travels back with the same path A to B and B to A. So in that case, displacement was zero. Upward positive, downward negative, right? 5 minus 5, 0, isn't it? And then we discussed about types of motion, uniform and non-uniform motion. Uniform motion means two words again, equal distance in equal interval of time. And non-uniform motion means, yes, unequal distances in equal interval of time. Very good. So we are done with the session. So before I end, I would like to remind you, thank you so much everyone for joining this session. Very, very grateful to you. Yes, this is what I want to remind you is that if you are not yet subscribed to our channel, please do subscribe by clicking the subscribe button and don't forget to click on the bell icon just beside the subscribe button on the YouTube channel so that you don't miss any of our live updated sessions. Okay. So hope to see you again in the next session. We are awaiting everyone's presence in the next session. So please take care, everyone, and please do study this topic from your textbook as well. Okay, we'll continue in the next session. Thank you so much from all of us from the team of Swiflearn. See you in the next session. Thank you. All the best.